All right. So we've got bell work up here that seems incredibly random. I wonder if it is truly random for us. So what do we remember about how to multiply fractions? So looking at this top guy here. What do we do for 3/4 times 5/7? Straight across. Cross multiply, what we're thinking of is when there's an equal sign in between. So that does not work in this case. There's no equal sign. So we go straight across. Straight across. So we're going to wind up with another fraction. That was the wrong spot. There we go. 3 times 5 is going to give us 15. 4 times 7 gives us 28. Will that simplify by anything? Will it simplify at all? No. 15 and 28 do not have any common factors, so we can't simplify at all. So when we're looking at fractions, we're looking to multiply across, straight across. What about for this next one? What can we do for our 4/5 times 3/2? I'm actually going to show us 2 different ways to do this one. We could actually just straight up do exactly like we did before, going straight across. 4 times 3 gives us 12. 5 times 2 gives us 10. Does that simplify? Because what are they both divisible by? 2. So I could put this as 6/5 because they both divide by 2. So you could do it like this and multiply things out to bigger numbers and then simplify. Or you can look at this and go, hey, wait a second. I notice that we've got in here a 2 and a 4. And we can simplify it out here. So this 2 can cancel out with one of the 2's and the 4, and you can do it like that. Which would then put us directly at our 2 times 3 being 6, 5 times 1 being 5. Either way is fine. Ooh, I didn't realize I was zooming in on my days here. Either way is fine how you go about this. We want to be able to get to that simplified version. So whether you multiply everything out fully and then simplify, or if you simplify as you go, that's totally cool. So, last one on this bell work. Thank you, dear. What happens when we try and divide a fraction? Ew. Ew. Back in the day, we had a little phrase that helps us remember what the heck we do with fractions and division.
Yeah, I don't.
We're going to definitely keep the first one the same. Do you remember what the rest of it is? Keep, change, flip. So we change the operation here. So it's going to change from division to multiplication, and we flip the second fraction. Yesterday during 6th period when I had one person in class. That's when that was. One person.
You only had one person.
One person. Oh, yeah. That class is regularly scheduled for review on senior script day. So we keep the first fraction exactly the same. We change the division to multiplication, and I'm going to take this guy and flip it over. So instead of being 1/2, it's going to be 2/1. So we do our keep, change, flip. Now what happens when we multiply this? Say it again. It is going to become 1 because I've got 1 times 2, which is 2, 2 times 1, which is 2. So we'd get 2/2, which is 1. Or we can go, hey, wait a second, those 2's cancel out, and we're left with just 1/1, which is 1. So I wonder what we're going to be doing with our rational functions when we spent our bell work multiplying fractions or dividing fractions when our rational functions are just fractions of polynomials. So I wonder what we're going to do today. Relevance. We are going to be in our notes packet on pages, we're going to do 5 and 6 today. So I'm just leaving it here for a second because I know we have a couple people that came in late trying to get things copied and or written down. But most importantly is that when we're multiplying fractions, we multiply across, straight across. When we are dividing fractions, that's when we're going to do our keep, change, flip. Options when it comes to simplifying. So let's take a look in our note packet on page 5. It has one of these up at the top. That page 452 is a reference to the textbook, which we use. So when we're looking at multiplying and dividing, this set of images here is 100% what we just did in the bell work. When we are multiplying fractions, we multiply directly across. A times C, B times D. Those are both denominators. When we have our fraction division, we keep the first piece, which is exactly the same over here. We change the sign from division to multiplication. And then our second piece flips. And then we multiply straight across. So these are doing the same things we just talked through. It's just giving you a place now inside your packet where you can remember that. So we're going to start by looking at this one. As that very first one on that page. We've got 3x over 8y times 12x squared y over 9xy cubed. And thus we begin to see why I made you packets, because writing that thing down would have been a pain before we even did any math. So what do we notice on this one? What are we gonna do? Multiply. So when we're multiplying fractions, we multiply across. And you can do this straight up where you take the numerator and multiply that and make it as big as possible. Or you can come through here and simplify just a little bit. Does anyone see anything that would simplify out?
I would say greatest common factor is 3, but 8 can't go. 3 can't go to 8.
No, but I can take a 3 out of 3 and I can take a 3 out of 9. They're all being multiplied together anyway. So we can simplify that down to a 3.
4.
And we could do a 4 with the 12. So that if I divide it by 4, that's going to leave me with a 3 here and a 2 here, because we divided by 4. That's what we're dividing by 4. The yellow was a divide by 3, just so that we see what was happening here. Anything else we see? It's okay if the answer is no. Cool. Then let's...
What about the x's and the y's?
What about the x's and the y's? I see a loose x over here and a loose x over here. Those guys can cancel. I see a very similar thing with the y's. I see a freelance y over here with a freelance y over here. So I can just I'm just taking loose pieces where I find them. It's like looking for loose change in the couch. If I see something that goes together, I'm going to drink it. So let's see what pieces we have left, because this is getting a little crossy-outy. So the things we have left, in our numerator, I have a 3x squared. And in my denominator, I have a 2 times 3y cubed. Are we fully simplified?
No.
What else do we have that could simplify out?
2 and 3. Multiply them.
Yep, we can do that. So we've got 3x squared over 6y cubed. Now are we fully simplified?
It's 1/2.
The 3 and the 6 can simplify a little bit more because I can take another color. This piece and divide it by 3. It's going to leave me with a 1 here. Dividing this piece by 3 is going to leave me with a 2. So our simplified answer here, I can't do anything more to simplify this. We have our x squared over 2y cubed. We're going to know we're done when I cannot simplify the numbers any further and I don't have the same letter in 2 different places. So I don't have x's in the numerator and in the denominator. I don't have y's in the numerator and the denominator. I only have them in one spot. Okay. Questions on this one? So these sometimes get really crossy-outy. And if you ever want colors to be able to color code it, let me know. I've got a gabillion. You can also just do it bit by bit. But you don't have to get it all the way done in the first go. We took a couple of rounds here to catch a few of them. So if you want to do it one step at a time, you can. It would take a very long time to do that. But just keep going until you can't really see what's happening anymore. And then rewrite it. Makes it a little easier. So questions on this one? Because this is our answer down here. This guy is our simplified fraction. You don't like the next one? I am always tired. That's my secret, Tony Stark. I'm always tired.
I swear to God, I'm always tired. Is it like a
Actually, kind of, yes.
really?
Insomnia is rampant. All right, let's look at this next one. We were unpleased with this one. 10d to the 5th over 6cd divided by 30c cubed d squared 4c over 4c. So first things first, when I see division, what do we think? Whenever I have a division symbol, keep, change, flip. Keep the first one, change the sign, flip the second one. Don't do any simplifying until you do that part. Careful, careful. So our first piece is going to stay the same. Our 10d to the 5th over 6cd. What is that? There we go. We change the sign. It goes from division to multiplication. And then we flip the second one upside down. So now we're going to have 4c in the numerator and 30c cubed d squared in the denominator.
Pretty new purple.
Oh, they're lovely, pretty new purple pens. What do we do now? Now I've got this down to multiplication. We're much more comfortable with multiplication, so I highly recommend we do that first. But what do we need to do next? Do we see anything that can cancel out?
The 10 and the 30 can divide by 10, and the 6 and the 4 can divide by 2.
Yep, so I can take the 10 and the 30 and divide both by 10. So I'm just going to say I was divided by 10 here. And then the 4 and the 6, I heard that one, they can both divide by 2. That's going to leave us with a 2 up here and a 3 down here. Bless you. Bless you. What else we see? C and C. I've got a loose C on the numerator of the blue fraction and a loose C in the denominator of the non-blue fraction. Well, at this point, I almost can't call it the black-colored fraction because it's been crossed out by too many things. It's the black and yellow and red and green. So at this point, it's getting a little crossy-outy, so let's see what we have left. So the things I have left in my numerator is I have a 2, and I have d to the 5th. In my denominator, I have 3 times d times 3 c cubed d squared. Boop. So that's a lot of letters loose in there. That problem is gigantic. Holy cow, I need to make that smaller. So bring this over here.
Can't you combine the D's?
Yeah. Let's simplify these a bit. Because we have too many versions of the same dang on letter in the same dang on line. So we have 2d to the 5th in the numerator. And in my denominator, let's do some simplifying. I've got 3 times 3, which gives me a 9. I've got d times d squared. So that gives me d to the 3rd. And then we also have that c cubed. Those 3's look weird, and I don't know why. There we go. So now what do we notice looking at this? What can I do with this? There's one more thing we can simplify.
The D.
Mm-hmm. So if I have 5 d's in the numerator and 3 d's in the denominator, how many are we going to have left over when we cancel things out? 2. And where are they going to be? Numerator or denominator? In the numerator. If I don't say numerator and try and write a 2, because that just does not brain properly. So we have 2 left over in the numerator, and then we have our 9c cubed in the denominator. So this will go down to 8, 2, and that one will go away. Because it's 5 minus 3. That's the way we do it with our exponents. So this is our fully simplified answer. The 2 and the 9 don't simplify down any farther. I only have 1 variable d in the numerator. I only have 1 variable c in the denominator. Questions on those two where it's all things that are just being multiplied anyway? Okay, because then we're going to look at the ones that have all the factoring fun in them.
Oh, yay.
Yay! Same vibe. We're going to do a multiplying one, and we're going to do a dividing one. So on the very next page, we get a problem like this. I warned y'all going into this chapter. This one is going to have 3 sets of factoring in it. Because we need to factor anything that has a squared term. So we're going to factor this guy. We're going to factor this guy. And we're going to factor this guy. This one's not squared, so it's pretty much already factored. So we can let that one ride. But we need to factor all of these pieces. And I promise I will show you why. So let's factor the blue one. That's the top left, our x squared plus 8x plus 15. Well, benefit of this is we have our shortcut that we can use, and we love that. What's going to go at the top of our x frame? What goes up here on the blue one?
15.
15. And what goes on the bottom? 8. Oh, I got to change this view so that you guys can actually see stuff. There we go. So we need a pair of numbers that multiplies to make 15 and adds to make 8. 5 and 3. So since we have an a value of 1, we can go straight into our factored form because we know we're going to have an x with a positive 5. And we're going to have an x with a positive 3. So we're going to have x plus 5 and x plus 3 is our factored form here. Telling you that shortcut is going to be a game changer on this one. So we're going to keep our x minus 6 in the denominator on this guy, just kind of chilling. Only thing I'm going to change is I'm going to put parentheses around him. It's the only thing I'm adding in. Then we're going to do the very same thing over on these right 2 pieces. Let's take our green one. This top left, x squared minus 9x plus 18. On the top of the x frame, we put our a times c, 1 times 18, so we get 18. Our b is -9. What pair of numbers will multiply to make a positive 18 and add to make a -9?
-3 and -6.
-3 and -6. When the top number is positive, we know both numbers are going to have the same sign. And since that bottom number is negative, they both have to be negative. So that means we're going to have factors of x minus 3 and x minus 6. One last factoring on this problem. You can use our x frame to do it. You can use x in box to do it. You can use our shortcut to do it. What pieces do we have there with our x squared and our -9?
A and C.
A and C. So my A is 1, my C is -9, so we have a -9 at the top. Our B, there's none there, so how many B's do we have? 0. We need a pair of numbers that multiplies to make -9 and adds to make 0.
-3 and +3.
-3 and +3. So we're going to have roots where x minus 3 and x plus 3. Because the other way we can do this is we can go, hey, wait a second, that's a difference of squares. So our first step when we're doing any of our multiplying or dividing with these rational expressions is we have to factor everything. Because when we're coming to do this multiplication, it's just like we did it in the ones that didn't have factors, where we're multiplying these together. So I'm multiplying top times top and bottom times bottom. And the way I kind of do this, and I'll show that I'm ready to do this visually, if you look at the screen. So I'm multiplying these two fractions together. Boop. They make one fraction. They're all being times together. They're multiplying across like this. So we can do that. It just puts a funky space in my fraction, but it does the same thing. So looking at this, can we simplify some stuff? Do we have anything that matches top and bottom, numerator, denominator?
Negative x minus 3 and x minus 3.
I've got x minus 3 and x minus 3.
There are multiple on this.
There are more than one. What else can cancel out? The x plus 3 and the x plus 3. Anything else?
X minus 6.
The x minus 6 and the x minus 6. Which means this whole thing simplifies down to be just x plus 5. This is our final answer. This is what it simplifies down to be. So if you ever went on Desmos and typed this in onto the graphing calculator, it would show you a line. And you'd be like, what? And it would be right. Because this has a lot of pieces that cancel out. You will eventually learn what canceling out stuff means to your graph. Oh snap, what? Next week. Questions on this one? I was going to say, because it's a little extra, but once we get the hang of it, it's not brutal. We got one more. Division! Huzzah! And it's going to be the same kind of vibe. We need to do our trick we have for remembering division, our keep, change, flip, and we're going to do our factoring. So we know for sure we're going to need to factor everything that has an exponent. So we're going to try and factor this guy. We need to try and factor this guy as much as we can. And those are my only things that have exponents on them. Everything else has a linear statement. So while I'm doing the factoring, I'm also going to do our keep, change, flip. So as we're doing this, I'm going to be doing the keep, change, flip process. So we keep this first fraction, which means when I factor this guy, it's still going to be in my numerator. So our a times c, our 1 times 12 gives us 12. Our b is 7. What is a pair of numbers that multiplies to make 12 and adds to make 7?
4 and 3.
4 and 3. So our factored form here is going to be our x plus 4 and our x plus 3. Our denominator is staying the same. I'm just going to put parentheses around it. Whenever we have a term that is not being squared, that still has addition, put parentheses around it. It will help, I promise. Our next piece is we need to change our operation. We had division, we're changing this to multiplication. What that means is on my next piece, I need to make sure that we flip this upside down. So what was in the denominator now needs to be our numerator. So now we're going to have this x plus 6 on the top. And we're going to factor this guy into the denominator. What do we notice about this 8x cubed plus 24x squared?
There's no x or number by itself.
Correct. So what does it have, since it does not have something that has just an x or a number all by itself? Does not have a 1 there. Do those two pieces have anything in common?
8x.
I was going to say, can I only take one x out of both pieces?
2 pieces.
Out of the greens.
It would be 8x squared.
8x squared. There's a GCF here. If we do not have a constant term, you have a GCF somewhere. So I can take an 8x squared out of both of those pieces. When I take 8x squared out of 8x cubed, I'm going to adjust an x. And when I take 8x squared out of 24x squared, what are we left with? 3. So the blue piece led to the blue piece down here. The green piece got flipped and put in our denominator down here. Questions on the factoring or the setup part? Because then what do we got going on? What can we do next? What can we simplify?
The x plus 6.
The x plus 6. Those guys are going to cancel out. Anything else? The x plus 3's. Bless you. If I have the same piece, top and bottom, numerator and denominator, we can cancel it out. It has to be 1 on the top and 1 on the bottom. You cannot do both on the top, anything like that. So we're left with our numerator of x plus 4. And in our denominator, the only thing we have left is our 8x squared.
There's x's involved.
There are still x's involved. Is that okay? Yes. Is there any other simplifying we can do? No. There is not. This is our answer. I just like to double check sometimes because once we write it without the parentheses, there will be somebody who comes in and goes, oh, sweet, get rid of the x's. That is not okay. We cannot do that. We can only simplify stuff when it's being multiplied, like these. It's got to be in factored form. So we cannot cancel things when there's a plus there. We can only cancel things that are in parentheses that have pluses. So this is our final answer here. Questions on this one? I love it because we have 8 minutes. Oh, cracked on that one. And homework 1 is technically due today. I'm going to give you guys homework 2. The homework 2 has what we did today and what we're going to do tomorrow. And we're going to continue practicing it on Thursday. But since we have skills check on Friday, I want to be able to get you guys like feedback as much as possible. So we'll figure out tomorrow, or figure out Thursday for sure. So I'm gonna give you guys homework 2, and the first 4 problems are what we did today. The rest of them are what we're gonna do the next couple of days. Because we've done multiplying, we've done dividing. We have to do that one, subtracting.
Oh, God.
I know. We only have 22 more days of school, guys.
It's also Earth Day.
Got one more chapter test, then final. You said your birthday?
Earth.
Oh, Earth Day. Yes, it is Earth Day. Happy Earth Day. You did the club thing after school.
I'm gonna be there because astronomy club is getting it.
I am not surprised.
We're gonna